infinity today. Today we investigate limits that approach infinity. You are used to this. If you have a function and you want to know the limit, you simply just plug it in. In many situations, such as polynomials, generally the case is that if it's continuous, it's nice behaving that the limit is f of a. But what if we approach infinity? Say you have the limit as x goes to infinity. Awesome. Go get some brain food. We'll come back. Okay. So suppose you had, say, x to the 7th, and you're approaching infinity. If you take a really, really, really large number, positive number to the 7th power, what are you going to come out with? Yeah. Now, let's change that a little bit. Suppose you take a very large negative number to the 7th power. So you're going to take a very large negative number, you're going to multiply it out 7 times, and you'll get out a negative number. Whereas if you had the limit as x goes to positive or negative infinity, if you had the limit as x goes to negative infinity of, say, x to the 8th, well, then what's going to happen to the negative? Yeah, you'll get positive infinity. So that's a little bit of the difference there. What if it was in the denominator? What if you had, say, the limit as x goes to infinity of 1 over x to the 8th? What's going to happen to the denominator? It's going to become ridiculously large, correct? Sometimes we use the capital letter N to represent a very, very large number. What is 1 over an extremely large number? An extremely small number. So it's going to get really close to 0. Does it matter if it's negative? Say I have the limit as x goes to negative infinity of 1 over x is 7th. Well, then you're going to get a very large negative number in the denominator, right? What's 1 over a very large negative number? Still a very small number. Yeah, I mean, if we look at a number line and this is 0, you know, in this situation, you come up with a number that's very, very close to 0, but on the right-hand side of 0. In this situation, you come up with a number that's very close to 0, but just on the left-hand side. Either way, it's approaching 0. Okay. Now we have some other interesting limits. Say the limit as x goes to positive or negative infinity of sine of x. Well, the graph of sine of x looks like this. So as x goes to infinity, does the graph of sine ever kind of zero in on one particular value? No, it never does. It just continues to bounce back and forth between positive 1 and negative 1. So this limit does not exist. Now instead of approaching infinity, I'm going to approach 0 to see if you remember the difference here. As I approach 0, the limit of sine of x over x, do you remember that one? It is 1. We learned that when we did the chain rule, or I'm sorry, the sandwich theorem, okay? But if I switch this and I go the limit as x goes to positive infinity of sine of x over x, well, sine is always going to stay between what two values? 1 and negative 1. But x, that's going to become ridiculously large, right? So you're going to have a small number over a ridiculously large number. That's going to go to, yeah, or 0. Sometimes you just look at the function and you start to make assumptions, like sine of 1 over x. That's your barcode function, right? As x goes to 0, the limit does not exist. But this question is, how about the limit as x goes to infinity? Well, 1 over a very, very large number is, or 0. So what's the sign of 0? 0. Cosine of 0 is 1. So let's apply our learning. Now, you may not like this right away, but trust me, you'll grow into it. We have to show and reason through our mathematics using the proper techniques that we showed above. In this situation, what we're going to do is we're going to take the limit as x goes to infinity, but we're going to rewrite the 4x minus 1. And this is what you need to kind of focus on today. We're going to factor out the largest term. And the largest term that we have is x to the first power. If I factor out that x, what am I left with? 4 minus 1 over x. Now, think about this. You're going to plug in a super large number for x. You get a super large number times 4 minus 1 over a super large number. Well, what's 1 over a super large number? It's 0. So you can see that this part is then going to go away, which makes it really nice. So you end up with 4 times a super large number, which is going to give you infinity. I took an x out of that expression. Yep. I just factored the x out. If I were to multiply the x back through, 4 times x is 4x, and x times 1 over x is 1. Now let me show you why we do that. You might be tempted to try to do this. You see the limit as x goes to infinity of x squared minus 3x. Right away, sometimes people plug in a very large number. They're like, well, I have a very large number squared minus 3 times a very large number. That's going to give me a very large number minus a very large number, and so I get 0. That's voodoo math. Because a very large number minus a very large number is not necessarily 0. It depends on, how big each one is. So a good way to work through this is to factor it out. So we take the limit as x goes to infinity of, what should I factor out? Factor out an x squared. And you're left with 1 minus 3 over x. Yep, your largest variable. Yep. So as I put in a very large number, I get a very large number squared times 1 minus 3 over a very large number. You don't have to continue to write that every time. I'm just trying to make a point with you for what happens here. So this goes to 0, right? And so you end up with a very large number squared, which is infinity. You try next one on your own. Ooh. If you square a very large negative number, you're still going to get infinity. That's correct. Yes. Sure. Yep. Either way, you'll still end up. Yeah. Okay. Now, again, a classic example. Somebody plugs in a very large number at the top, they get a very large number. Plug in a very large number at the bottom, they get a very large number. They're like, oh, the answer is 1. No. Like, well, infinity divided by infinity is 1. No, it's not. We don't know. It's like 0 divided by 0. And it's an indeterminate value. So here's what we're going to do. We're going to take the limit as x goes to 0 of, I'll factor out the x, and in the bottom I'll factor out the x. Whoop. So yeah, so right here the x's go away. And the 1 over x goes to 0. So what are we left with? 2 over 1. So in this case, infinity divided by infinity gave us 2. You try next one. A very large negative number, yeah. Nope, nope. So on the top, you're going to take out x to the third. On the bottom, you're going to take out x squared. To make an x. So this just becomes an x in the numerator, right? So 4 times a very large negative number divided by 1. Or did you do it? That's fine. Nothing to factor out of the top of the next one, but the bottom I factor out x squared. Right? So, no, give me a, this is a very big number squared, right? What happens when you take a very big number and you square it? Get another bigger number, like, I don't know, we'll pick a big number here. We got 10 quadrillion here. 6 divided by 10 quadrillion, you're going to have a super tiny number, right? 0. And it sounds like 10 quadrillion is a really big number. I mean, it's not when you compare it to the infinite set of numbers. So. All right, I'm going to give you a little hint here. Where do you see the larger degree? In the numerator or the denominator? So if the denominator is bigger, what do you think we're going to get? So you can see that the 2 over x will go away. So I get 3 over a super large number. Next one, I take out a, oh, and this was great. You know, some people might go in here and might be like, well, I'm going to take infinity, and I'm going to add infinity to it, and I'll get 2 infinity. Can't do that, okay? We got to reason through it. Yep. So we know the 2 over x squared is going to go to 0. And so we end up with 8 times a very large number cubed, which will be infinity. Where do you see the larger term in the next one? The top. So what do you think you're going to get? Or infinity or negative infinity? If the top is larger degree, then you're going to end up with positive infinity or negative infinity. So we got to think that through a little bit here. So go away. So that limit is x goes to negative infinity. I'm going to take out an x squared. It's so fun. 6. It's okay to give in to the temptation. Some of you are resisting it. You really love it, but you're afraid to admit it. So this goes away. This goes away. One of the x's goes away. So I'm left with negative 6 times a very large negative number over 1. So I get, so you notice you got to be careful with your negatives. And if you get a negative wrong on this test, I don't take off a half point, I take off a whole point. Because there's a big difference between positive infinity and negative infinity, okay? It's a big deal. Sometimes to check your answer, you can just think about the graph. What does that graph look like? It's a parabola that's upside down, right? So as x goes to negative infinity, what will y go to? Negative infinity. So we should get negative infinity. Let's try. Yes, you need to show your work. I know it's so much work. So I get negative 3 times a very large negative number squared, which will be a very large positive number times negative 3, which will result in negative infinity. Where is the larger power in this one? Neither. This is important. Shh. This is important. Watch. When I look at this, you say 1. I say negative 2/3. Here's what happens, folks. Aren't you noticing that every single time, all the smaller terms go away anyway? We'll be left with a 4x over negative 6x, which is a negative 2/3. Watch it happen. Because on the AP exam, I wouldn't do all this work. I would just look at it and say it's negative 2/3. Watch. Trust me, you guys, you're capable of doing it. And I'll show you another way in a month here. I take out an x. You won't. Last time I checked, it's a little shorter this year. So. Oh, you're right. All right. Okay. So I told you guys that like the 1 and the 5, you see how those just go away? They're gone. And since they're to the same power, we factored the same thing on the top and the bottom. So those will be gone. You're left with the 4 over the negative 6, which is negative 2/3. Boom, done. Yes, you do. And the reason why is, here's the reason why. I used to not have people do this, and I ran a situation, A, when I was at college, yes, I had to show that all the time. And B, I've had students that have gone on, and yes, they have to show it. I will give you plenty of opportunities where you don't. But on this test, you do. Just this test, okay? So let's just see how easy this could be. You're on the AP test. You look at it. What do you notice? Bigger on the bottom. So as you said, Caleb, 0. larger degree in the denominator. Sure, we'll show it out. I get 9 plus that big number over x to the 4th, x to the 5th minus, or times 1 minus that big number over x to the 5th. So you can see that these go away, and all the x's will go away in the numerator. You're left at 9 over a very large number, which is 0. Yes. What do you think we factor out of this one? I'm going to factor out an x squared. And when I factor the x squared out of the square root, what does it become? What is the square root of x squared? X. So when I factor the x squared out, it becomes x. And I'll be left with a 5 plus 2 over x squared. Took an x squared out. If I take the x squared, I'm left with 5 plus 2 over x squared, or 7x plus 1. If I take the x squared out, which is a perfect square, I therefore get x times the square root of 5 plus 2 over x squared. What do I factor out of the bottom? You notice the x's go away. 2 over x squared, 1 over x goes away. I get the square root of 5 over 7. Yes, you try the next one on your own. What time do we go to today? Okay. We gotta hustle. Forwards 2. So we'll finish off those rest tomorrow and into our next lesson. These are the problems you should be able to get through, though. So maybe not the last couple, but all the others you'll be fine. So. Which one? Sure.